Morning students. So today I'll start a new unit 4, and from the chapter Boolean algebra. So today we shall learn about what is Boolean algebra and what is the use of this Boolean algebra in computer, okay, and how do we implement this Boolean algebra. So what is Boolean algebra? So the algebra that deals with only two quantities, true or false, is called Boolean algebra. So much uh, before we started this Boolean algebra, I have already explained the word Boolean, right? We have used that in the uh, data type, Boolean data type, and then we have seen that in relational and logical operators also, where the expression always evaluates to two conditions, that is true or false. So that is Boolean, right? So now the true true the truth value true is denoted by 1. So here true is indicated by the number 1, and the truth value false is denoted by number 0. So either it can be true or false, or 1 or 0, right? So how is Boolean algebra used in computers? So not only computers, but in all digital circuits that performs logical and arithmetic operations, the concept of Boolean algebra is applied. So since computer can understand only binary language, that is machine language 0 and 1, okay, so by using a Boolean algebra, since Boolean algebra also is based on only two conditions, that is true or false, or 1 or 0, right? So designing the digital circuits becomes much easier and simpler using the Boolean algebra in the digital circuits. Yeah, so it becomes much faster to uh, design the digital circuits using this Boolean algebra. So all the digital circuits that is found in your mobile phone, your laptop, okay, tablet, computers, all of these things are designed using this Boolean algebra concept only. Okay. Now truth table. So truth table here is a tabular representation of all possible values of logical variables with all possible outcomes for the given combination of values. So truth table is a tabular or table representation in rows and columns format, okay, to uh, to represent the variables which are used in the Boolean algebra, okay, and then the values that are stored in the variables, okay. So based on the number of inputs stored in the variables, okay, so based on the number of inputs, okay, all the possible outcomes after evaluating the variables will be generated using the truth table. So to express the Boolean algebra, okay, truth table is used. So now it consists of two parts, that is rows. So the number of horizontal row in the truth table depends on the number of input variables. So like example is two variable values, okay, so two variables, and in two variables two values, so that will generate four possible outcomes of rows in the truth table. So based on those two values, okay, it can generate four rows, that is four possible rows of either true or false in the truth table. So the column represents the vertical value. So more on truth table we'll see in the following pages. Now some of the terminologies that you use in Boolean algebra, that you see in Boolean algebra, is the first one is the logical statements. So these logical statements can take only two values, either true 1 or false 0. So in terms of the logical statements, okay, there is a single statement based on one expression, that is like you have seen that in relational expression, right, where a single statement takes two variables, two values, and comparison is done between the two variables, or the two values stored in the variables, so it comes to either true or false. Now the logical constants, okay, the values of logical statements, so the values that are stored in the operands or the variables, okay, so that values can also be only of two type, either the value has to be uh, true or false, or the value has to be 1 or 0, okay. So all the digital circuits are uh, designed using the this concept, that is 1 or 0, clear. Now, so binary valued variables, that is the variables, okay, which are used to store the two values, that is the either true or false. Now, compound statements, logical statements with logical operators form compound statements. So here we have two variables, a single statement, okay, and based on that, okay, it can take two values and the outcome will be true or false. Now in compound statements, okay, we can have more than two logical statements, or two logical statements, or three logical statements, where compare it can be based on more than two variables or three variables, like that. So where we use the logical operators such as like and, or, and not, okay, so that is termed as compound statement, right? Now these are the following logical operators that are used in Boolean algebra. The first one is not or negation operator. So this operator is also called as complement, okay, and this is a unary operator which executes or operates on a single variable only, and this not operator is represented by this symbol tilde or single quote, okay. So now if a is true, then the not operator will show that it is false, okay. So if suppose a value is 1, then the not operator uh, will display 0, okay, and if a is 0, then a naught will be 1, okay. So that is represented, it can be represented in truth table as, suppose these are the two variables, okay, and so if the value of x is 0, okay, then y will store the value 1, and if the value of y is x is 1, okay, then y will store the value 0, or it can be represented in this format, okay. If this is a, okay, and this is a naught, okay, then in that case if a is 0, okay, the negation of a will be 1, or if a is 1, the negation of a will be 0, okay. So opposite. Now AND or conjunction operator. Now it can perform multiplication on two operands or variables, okay, and it is represented by the dot symbol, so that is called as a dot b or a and b, like that, okay. So this statement is true only when both the values are 1. So here you can see in the truth table that we have the variables x, y, z, okay. So here when the values stored in the operands are both 0, so like 0 dot 0 or 0 into 0, then outcome will be 0. And when uh, one of them is true and the other one is false, okay, then also it will be 0, okay. Then only it will be true only if both are 1. Then when both are 1, the outcome will be true, okay. So this should be here, this should be uh, 1, okay. So 0 0, okay, 1 0 0 1, clear. So in any way, whether x is 0 or whether x is 1, and if y is 0 or y is 1, okay, then it will be 0 only. So just like the normal logical operator, okay, only when both the expressions turns out to be true, or both the values are 1, then you will get the output value as 1 or true. Now or disjunction operators. So or operators performs addition on two variables, okay. So if you want to perform the arithmetic addition, you use this or operator. So it is represented by the symbol plus. So here the statement is true if any one of the values or both the values are true or 1, okay. So as you can see here, since the these are the operands and it can accept only two values, that is either 0 or 1, and no other numbers, right? So it can accept only 0 or 1. So this is used to represent the digital circuit. So when both are 0, okay, so 0 plus 0, it will be 0, 0 plus 1, it will be 1, okay. If any one of the operand values are true, then the outcome will be true. So Again, here, yeah, here also it should be 1. Okay, 1 0, then it will be 1. Then finally, if it is both 1 1, then the outcome also will be 1. Okay, so this is how you use the logical uh, operators to, and then you use the truth table to represent all these operators. Okay, so go through these operators, go through the truth table. Okay, and then from the textbook also go through the examples. Okay, and then tomorrow we shall continue on with this chapter.